more details about how to do this derivative. Okay, so if you've got this number c in front of a function, you can think of it as carry the number c along and then take the derivative of the function. So think of it with this example. I carry the number 4 along, and I do the power rule on x cubed, which is 3x squared. So you don't need to write this intermediary step. You can just write 12x squared. Okay, this is an important rule. It looks easy, but it's hard to remember it. So the derivative of e to the x is e to the x. So if I'm taking the derivative of 6 times e to the x, I carry the 6, because that's a constant, times the function, and then the derivative is just e to the x. So if I've got several functions, I'm just here showing examples of 2 being added or subtracted together, you just take the derivative of each of them. Okay, so here I've got 4 different functions. So let's just go do it. You don't have to write all these steps out. So I'm going to carry the 3 along, take the derivative of x to the 4th, and that gives me 4x cubed. Carry the negative 2 along, take the derivative of e to the x, which is e to the x. Take the derivative of x. Okay, so let's go slow. So if I'm taking the derivative of x to the 1 power, that's like saying 1x to the 0. Oh, that's just 1. So the derivative of x is just 1. The derivative of negative 3, that's 0, because negative 3 is a number. So that is the answer. It is important that you rewrite it so you see x to a power. So here I have a big quotient, so I must rewrite this so that I'm going to separate it around the addition and subtraction in the numerator. So I get x squared over x plus 3x over x minus pi over x. And I just went slow so that I could simplify it next. And now I'm going to rewrite this as the exponent that it is, which is pi x to the negative 1. Now I can take the derivative. So the derivative of x, remember, is 1, right? We just did that. The derivative of 3 is 0, so I don't need to write 0. And I bring this negative down, so that turns into plus pi x to the negative 2. And that's the derivative. All right. Ooh, looking ugly here. So it's got t's in here, right? So find the derivative. So let's take time to rewrite it. It can be really, really helpful. So that stays the same. That stays the same. Okay, let's do this one. 2 times, and this is going to be t to the negative 1/3 power, and then that last term e cubed. So another way we can write the derivative is just y prime. It doesn't have to be f prime. Okay, so the derivative of e to the t, so let's remind ourselves, the derivative of e to the x is e to the x, so the derivative of e to the t will be e to the t. So I get e to the t. This term here, different color going, t to the e, that is the variable t to the number e. So we're going to use the fact that if I know that derivative of t to the e, derivative of t to the n would be n t to the n minus 1, right? So I'm going to bring that e down and then subtract 1 from the exponent. So notice that's all in the exponent, right? Okay, so moving on to the next term, bringing this exponent down, so I'd have a negative 2/3, and then I'm going to subtract 1 from the exponent, so I'd get negative 4/3. And then you know the derivative of e cubed is 0, so I don't need to write anything. And that's a fine answer, just like that. Okay, anytime you see a function, this could be written f of x, right? Function of x, and it has a, b's, and c's, and d's. Just know that they're numbers, right? So let's take the time to rewrite this. So this 1 over a, that number stays there, so I get x to the negative 3. And then b, and that would be x to the 1/2. And then nothing really to rewrite in these last 2 terms, but let's just carry them along. Okay, staying organized and neat is crucial. All right, so now let's go take the derivative. So I'm going to bring this exponent down, so I get negative 3 over a, subtract 1 from the exponent, so I get x to the negative 4. Then I'm going to bring this 1/2 down in front, so I get b over 2, x to the negative 1/2. And now I'm going to take the derivative of 1 over c times x. If I bring the 1 down, I get 1 over c, and then I would have x to the 0. But what do we know x to the 0 is? It's 1. Okay. And then what about the derivative of negative d? You know that that's 0 because that is a number.